The purpose of proper field inspection, based primarily on control tests, visual observation, and good judgment, is to assure that the results set out in the plans and specifications are obtained. As a guide to inspection and control of soil cement construction, the Portland Cement Association has made available the Soil Cement Inspector's Manual. This film is based on the contents of this publication. Field inspection involves the control of 5 factors: cement content, moisture content, mixing, compacting, and curing. The inspector can easily control these factors by organizing the inspection steps into a routine that fits in with the sequence of construction operations. Since the strength and durability of the pavement depends to a great extent on adding the correct amount of Portland cement to each soil material encountered, the inspector's first job is to review carefully all information contained in survey reports, plans, and laboratory test reports, and then to check these data with actual materials on the project. At the construction site, the inspector should make sure the construction equipment has been checked prior to operation. Special attention should be given to the mixer to be sure the tines or paddles are in place, in good condition, and operate smoothly. The cement truck hitch must be checked beforehand. The cement spreader must operate smoothly to ensure uniform cement application. Truck scales must be accurate and in good condition. Motor graders must be checked to ensure good working order. Grader blades should not show excessive or uneven wear. The source of mixing water should be inspected for possible contamination, and the pump checked for condition and capacity. Because an adequate water supply is critical to high-volume soil cement production, the water application system must be checked for even, adequate flow and distribution. Careful attention must be given to the preparation of the roadway before processing begins. The soil is loosened by the scarifier on a motor grader. Loosening the soil shortens the mixing time. The area is shaped to approximate crown and grade. Since there is little displacement of material during processing, the grade at start of construction influences the final cross-section. Soft subgrade areas are easily detected by observing the stability of a section when heavy equipment passes over it. Soft spots may be corrected by opening the spongy areas or removing the unstable soil and replacing it with dried out or satisfactory borrow material. To guide the equipment, stakes or markers are set along the pavement edge to control the width of treatment during cement spreading and processing operations. Pre-wetting is common practice if the soil material is dry. Water should be added uniformly. Applying water at this stage saves time during actual processing because most of the required water will then have been added. Pre-wetting very granular materials prevents the cement from sifting to the bottom of the mix by causing the cement to adhere more readily to the sand and gravel particles. By mixing the water in, evaporation losses are reduced. Bulk cement is used on most projects and is distributed by a mechanical spreader. To assure a uniform application of cement, the spreader should operate at a constant speed with a uniform quantity of cement in the hopper. A chart contained in the inspector's manual may be used to determine the correct quantity of cement for each unit length of spreader travel. Assume that, based on laboratory tests, 6.9 pounds of cement per cubic foot of compacted soil cement is required. The base depth is 6 inches, and the spreader is 8 feet wide. The chart shows that 27.6 pounds of cement are required for each lineal foot. When a mechanical spreader is used, a spot check may be made to determine the accuracy of the cement spread. After the spreader has passed, A square yard piece of canvas that was placed on the roadway ahead of the cement spreader is carefully picked up and weighed. Loops at the corners make it easy to gather together and weigh the cement and canvas. An additional check on the quantity of cement spread is made by measuring the distance covered by one truckload of cement of known weight. If the load spreads a shorter or longer distance than calculated for the desired cement content, the spreader is adjusted accordingly. On some jobs, cement is applied to the top of a windrow of soil. And mixing of the soil, cement, and water is done in a windrow-type traveling pug mill. Charts show how much cement is needed per unit length of windrow. The quantity applied can be checked by measuring the distance covered by the spreader. When central mixing plants with batch-type mixers are used to mix the soil cement, it is necessary to proportion the soil aggregate and the cement before they enter the mixing chamber. The aggregate material, cement, and water are measured out separately for each batch before transfer to the mixer. With continuous flow pug mill mixers, one method of calibrating the plant is to determine separately the quantities of soil material and cement that are fed to the mixer during a given period of time. First, the soil material is fed through the mixer for 1 minute, discharged into a truck and weighed. A sample is taken of the material that went through the mixer. The sample is dried to determine its moisture content. The dry weight of the soil material being fed through the mixer is then calculated. Then the cement feeder is run at a selected RPM and the cement is collected for a set period of time. After the cement is weighed, the feeder is adjusted until the proper proportion of cement to soil material is attained. A second method of calibrating a continuous flow pug mill is to determine separately the quantities of soil material and cement that are fed onto the main conveyor belt before entering the mixer. The soil material is fed at a selected gate opening, and the material on a measured length of conveyor belt is collected and weighed. The moisture content is determined to obtain the dry weight of the material. The cement can also be collected from a measured length of belt, weighed, and the cement feeder adjusted if necessary. Any method can be used to determine the correct proportion of cement to dry soil material. Cement properly spread on the job is mixed with the soil material in place. In order to estimate mixing water requirements, representative moisture samples are obtained from the raw soil prior to mixing or from the soil cement mix before water is applied. The moisture content is then determined. Some agencies use a calcium carbide gas pressure tester, in which only a small sample of material passing the number 4 sieve is used. The inspector, working with results from laboratory tests, estimates the quantity of water to be added. In making an estimate, the inspector considers the moisture already in the material and allows for some loss by evaporation. Water required per unit length or per minute for 1% moisture can be determined from the appropriate chart. Water is added and blended uniformly into the soil cement mix until a uniform color is achieved. The correct amount of water is called the optimum moisture content. It is important in soil cement construction because the proper amount of moisture is required for adequate compaction and cement hydration. 8 or 9 inches of loose soil cement is usually needed to produce a compacted base 6 inches thick. Soil type will influence the relationship between the loose depth of the mixture and the depth of the compacted soil cement. During mixing, the inspector checks the depth, width, and uniformity of the mixture. Color will indicate if the mixture is uniform. With experience, The inspector will soon learn to judge the moisture content by feel. A sample, squeezed between the hands, may be broken into two parts without crumbling if the moisture is at optimum. Prior to the start of compaction, the inspector lifts a sample of the soil cement from the area being processed. With this sample, he runs a field moisture density test to determine the optimum moisture and maximum density to be used for field control of the section under construction. The soil cement mixture is compacted in a standard moisture density mold. Care should be taken that the equipment is set up on a solid, level work area. The optimum moisture content is that content at which the greatest dry density is obtained in the test. Known as maximum density, it represents the approximate density to be attained in soil cement construction. The moisture content of each trial is determined, and the calculated dry weights are plotted against the moisture content to form a moisture density curve. Certain areas will require special attention. The inspector must make sure that mixing is thorough at construction joints and near concrete gutters, pavements, or other places where space is limited. The soil cement mix should be pulled completely away. The soil cement pulled away should be thoroughly mixed and then replaced for compaction. Existing manholes should be removed and the void bridged so that spreading operations can move straight down the roadway and full depth mixing can be achieved. Most soil cement is built from materials that require little or no pulverization. A simple test is made by screening a sample through a number 4 sieve to check the degree of pulverization. Any gravel or stone retained is discarded. The portion that passes is weighed. Then the total sample is weighed. The weight of the mixture passing the sieve divided by the weight of the total sample multiplied by 100 gives the percent passing the sieve. If less than 80% passes, pulverization is inadequate. Central plant mixed soil cement is hauled to the site and placed on the prepared subgrade. It is spread either full or half width of the roadway with a spreader. Compaction is divided into 2 operations: initial compaction and final compaction. Initial compaction begins immediately after mixing is completed. A tamping roller is generally used except for the more granular soils. The heaviest roller possible should be used to achieve compaction without overstressing the soil. Gravelly or sandy soils may be compacted with vibratory steel wheel rollers. Other soils, such as cohesionless sands, may be compacted using pneumatic tired rollers. During compacting and finishing, the surface may tend to dry, especially if there is a hot, dry wind. Adequate surface moisture must be maintained to assure a tight surface free of cracks or ridges. The area is shaped with a motor grater. Final compaction is obtained by a pneumatic tired roller, or if the soil contains gravel, a steel wheel roller may be used. After final rolling, density should be determined at several locations on the first few sections completed. In-place density determinations can be easily accomplished with a small, portable, nuclear density meter. A hole is made, and the meter probe is inserted. A reading is obtained in about 1 minute. Its use simply requires periodic calibration. A common method used to determine in-place density is the sand cone method. The test is made by digging a hole to the full depth of processing. All material removed is carefully salvaged for dry weight determination. The volume of the hole is determined by filling the hole with uniform, clean, dry, free-flowing sand of known density. Density is determined by dividing the dry weight of the salvaged soil cement removed from the hole by the volume of the hole calculated from the weight of sand required to fill it. The rubber balloon method is also used to determine the volume of the density test hole. These in-place density tests are the same as those for soils or for granular materials. If the in-place density test sample contains a different amount of gravel or stone from the moisture density sample, a density correction is required. A chart is available in the inspector's manual for this purpose. Other methods of compaction control are used by various agencies. After necessary adjustments are made, only routine daily density checks will be required. An application of phenolphthalein solution will turn red in the presence of unhydrated cement. To accentuate the color difference between the subgrade and the soil cement mixture, then the compacted depth is measured. Before curing, the inspector makes certain that the surface is free of loose material, smooth, dense, free of ridges, cracks, and surface compaction plane. Adequate curing of soil cement is necessary to permit cement hydration to produce a hardened material. A small amount of water is added to fill surface voids. Then, only enough bituminous material is applied to form a moisture-retaining cover over the surface. Today, contractors everywhere, using modern equipment and mass production methods, are easily building large daily volumes of soil cement. The quality of these pavements depends on the vigilance of the job inspector. By learning the few basic steps of soil cement inspection and organizing them into a logical daily routine, inspectors can easily keep pace with the construction. All of the testing procedures covered in this film, as well as sample problems, tables, and charts, are covered in the Soil Cement Inspector's Manual. Other publications, helpful as references for the inspector, are available from the Portland Cement Association.